Hello students, today we will discuss on the topic that is viscosity of liquid. This is one important characteristic of every liquid. We have seen in our day-to-day life that some liquids are very thin, easily flow, but some liquids are very high denser liquids and their fluidity is very slow. If you see, very slowly they are moving. For example, honey, glycerin, that your pitch, these are high viscous liquids, you can say. So this change in behavior of liquid that some liquids flow easily, some liquids cannot flow fastly. Water flows easily, smoothly, but your mustard oil and your honey, if you see, glycerin flow very slowly. So this difference in properties of fluidity of liquid, some liquid flow easily, some cannot. This property can be explained using the concept, that characteristic, that viscosity of liquid. So some liquids can easily flow, some liquid cannot flow easily. So this difference can explain that as liquid, the intermolecular force exists between the molecules of liquid. When generally liquid flow in the form of layers, liquid generally flow in the form of layer. If you see, it will flow in the form of layer, that is called laminar flow. Laminar flow. This is a very common one. Laminar flow means in the form of layer. In the form of layer. First layer, second layer, like this, in the form of different layers, liquid flow. So as the liquid molecules attract each other, so this attraction of liquid layer, if you see, one layer attract another layer. Due to attraction, the movement is restricted. The movement becomes slow. This property of liquid opposing the flow of other layer is called viscosity. So what is viscosity? If you write that viscosity, it is the property of liquid which opposes the flow of other layers. It is a property of liquid which opposes the flow of other layer. One layer opposes other layer. This property is called viscosity. And viscosity, it mainly depends upon the intermolecular force between two layers. If the attraction is more, then the opposing tendency will be more, so liquid flow easily. Cannot flow easily. That's why this attraction can be expressed in the form of what? Force. If the attractive force is more between two layers, between the molecules of two layers, then liquid flow will be slow. So this force, attractive force between two layers, is directly proportional to the area of area. That means how much area covered by the liquid. How much area? That is cross-sectional area, you can say. If the area is more, then force will be more. And this force, it is observed also, is directly proportional to velocity gradient, that is dv by dx. What is dV by dx? dV by dx is called velocity gradient. Velocity gradient. What is velocity gradient? We have seen when the liquid flow in the form of layer, if suppose this is, you can say this is your tube, like this. Then this is your layer, first layer, second layer, like this. Flow of liquid. But it has been observed that the liquid velocity, the velocity of liquid is maximum at the center. At this point, velocity is max. Suppose it is V is the velocity at the center. Then, if you move upward, velocity decreases. If you move downward, velocity also decreases. Velocity is maximum at the middle point. With distance, velocity changes. Generally, velocity decreases from center to top and center to bottom. And this is the maximum point. So, with a distance, velocity changes. That's what is called velocity gradient. Change in velocity for distance. From the origin. If you start from origin, or you start from the bottom, or start from the top or bottom, velocity changes. So, how much velocity change for a distance, that is called velocity gradient. So, force is also directly proportional to velocity gradient. So this force, if you combine, this force is directly proportional to area, means suppose A. So A into dV by dx implies this force is equal to some constant eta. This is the symbol of constant eta. A into dV by dx. What is eta? Eta is called coefficient of viscosity. This is called coefficient of viscosity. So that force is equal to eta. Force will be eta. The coefficient of viscosity of liquid will be equal to intermolecular force when area is equal to 1 centimeter square and the velocity gradient is equal to 1. How much? Second inverse. What is the unit of velocity gradient? dV is equal to, velocity is equal to centimeter per second. By dx means centimeter, cancel. So answer is second inverse. So this is the unit of velocity gradient, that is second inverse. So if velocity gradient is 1 and area is 1, then that force between the two layers is equal to coefficient of viscosity. So coefficient of viscosity is the unit to measure the viscosity of liquid. If your coefficient viscosity is more, that means your viscosity also more. That means force attraction is more. If force is more, that liquid flows slowly. If air is more, liquid flow slowly. If intermolecular attraction is more, then liquid flow slowly. So F is equal to eta when area of cross section is equal to 1 centimeter square and velocity gradient is 1 second inverse. So this eta, I can write the unit of eta. Now eta is equal to, what is the expression of eta? Eta is equal to, if you see here, eta is equal to force into how much? Force by, that is force. Here you see it is force by area into dV by dx. You put the unit. Suppose in CGS unit, your force is equal to dyne. Force unit is dyne. Dyne, then area is equal to centimeter square. Then dV by dx unit is second inverse. Then what is the unit of eta? That is coefficient of viscosity. Coefficient of viscosity is equal to dyne, then centimeter minus 2, then second. This is the unit of coefficient of viscosity. Then d centimeter minus second. This is the unit of in CGS unit of eta. And this unit, this is equal to 1 poise. 1 poise. Remember, this unit is 1 dyne per centimeter square second is equal to 1 poise. This is the CGS unit of coefficient of viscosity. Poise. 1 poise is equal to 1 dyne centimeters per centimeter square and second. If you express eta in another form, eta is equal to, as it is equal to force by area into dv by dx. Force is equal to mass into what? Force is equal to mass into acceleration, then area, then dv by dx. You put the value, here you put here, then what is the unit mass? Mass is gram and area is equal to centimeter, acceleration is equal to centimeter per second square, centimeter per second square upon area is equal to centimeter square and dv is equal to second inverse. Then what happens? What is the unit of this? So eta is equal to gram, then centimeter inverse, then second inverse. You see, gram, MA, acceleration is centimeter per second square, then area centimeter square, divided by second inverse, then second inverse will go, that is second inverse remain, then second inverse, centimeter inverse. So this is the one. So eta is equal to 1 gram per centimeter per second. This is also called 1 poise. 1 poise is equal to this much in terms of 1 gram per centimeter per second inverse, or is equal to 1 dyne per centimeter square into second. So this is the unit of poise. Again you can check it. Mass is equal to gram, then acceleration centimeter per second square, then area centimeter square, divided second inverse, so that is second inverse, then centimeter. Okay. So this is the unit of what? Coefficient of viscosity. Eta can be expressed in MKS unit is equal to Newton meter per meter square into second. You also express in this unit. This MKS unit, this is the CGS unit. But remember poise. Poise is very important. 1 poise is equal to 1 gram centimeter inverse second inverse. So this is the expression of what? Expression of coefficient of viscosity. Now this coefficient of viscosity, what are the factors affecting viscosity? What are the factors? Factors affecting viscosity. First factor already know, that is nature of liquid. This is nature of liquid. Nature of liquid, you know, if intermolecular force is more, then automatically force is more means force and viscosity just same when area of cross section is 1 and velocity gradient is 1. That means force is equal to coefficient of viscosity. That means eta is directly proportional to intermolecular force. That means your glycerin is more viscous than honey, is more viscous than water. Like this. So we can say that if intermolecular force is more, then viscosity is more. So this is the one factors that if you change the liquid, viscosity will be changed. Then second, very important second point is, that is temperature. Eta is inversely proportional to T. Because if you increase the temperature, intermolecular force will break. If intermolecular force is breaking down, then your viscosity will be decreased. Viscosity decrease means liquid can easily flow. That's why hot water is less viscous than cold water. Hot water flow easily compared to cold water. So this is the difference. Viscosity. Viscosity means velocity. High viscous, if you see high viscous, flow is slow. If liquid is high viscosity liquid, that means flow is slow, slowly flowing. That is, liquid has one property that it can flow. Flow means sliding of molecule one another, that is called flowness. So more viscous means slowly flowing. So hot water less viscous than cold water, because hot water the intermolecular force is breaks due to temperature. The third factor is, if you add that covalent substance increases eta. Eta will increases. If you add oil to water, then viscosity is more. Oil water is more viscous. Oil water is more viscous than water, because oil is a covalent substance mixed in water. That's why if the substance is highly soluble in water, then viscosity decreases. So, for example, fourth point is salt. Salt decreases viscosity. Salt decreases viscosity. If you add salt to water, viscosity decreases. That means liquid is more free, more mobile, more free. That means salty water less viscous than water. Salty water is less viscous than water. So these are some important factors related to viscosity. So viscosity also very much important. If you add more and more salt, if excess salt will be added, then it will be less, it will be more viscous. So that if a little amount of salt is added, little amount of acid is added, then the viscosity will be decreased. But if you add excess solute is dissolved, excess substance will be dissolved, then automatically the flowness of water will be decreased. That's why viscosity also will be affected by different factors. So this is regarding the viscosity of liquid. Is very important property of liquid. Every liquid has viscosity property. It is opposing the flow of other layer, and it is measured by the unit coefficient of viscosity. And coefficient of viscosity is expressed as force per unit area or unit velocity gradient. If area is 1, velocity gradient is 1, then that force acting between the layer, that is called viscosity. So more force, more viscous. So this concept we have to remember regarding the property of viscosity of liquid. Okay, you practice more for your develop for better knowledge, and it depends upon your practice. Okay, thank you all.